So guys, I hope everyone have a good night, good happy Thursday. So thank you FirstMark and Kojan for first of all having me. So I'm going to talk about how to break up the Rails Monolith. We just started doing it, but I want to tell you how we started to do it compared to how other companies have started to do it. So let me tell you a little bit about myself. I'm still on my first year as a developer. For probably 3 years ago, you'll still see me as a personal trainer. So I was still, you know, trying to train people, and often it would turn back around as they get upset at me. So, I barely got into DigitalOcean on the support team, and then I eventually went to Turing School in Colorado. Turing School is basically, I don't know if you heard of G School, but I'm pretty sure many of you heard about the Flatiron coding school and General Assembly. Those are 12-week coding schools. This one is 27 weeks. 27 weeks, 10 hours a day, so it was a little more intense, and it was a ton of fun. So for those who don't know what DigitalOcean is, we do cloud hosting, which means that if you need to host your blog, a server, a VPN, something to play videos, you need to put that on the internet, and basically we can help you do that in an easy way. You can also do that in a lot of other web services, but we like to think of ourselves as very simple and very easy for any type of person, especially for the developers, as we have great tutorials to help you do step by step. So I just wrote a blog about my journey and many missteps along the way. So if you want to read about that, it's on Medium. So let's talk about a little about why we chose Rails being Rails. So being a cloud hosting company, you would imagine that we write libvirt, we do KVM, we do Go, which we do all of that, even Perl. Because five years ago, Perl was a cool thing to do, right? I mean, many of you may know that Perl was a hot thing back then. So a lot of our code is in Perl, and we were very happy this year that we finally got rid of our V1 Perl code base. So we finally got rid of that. So that was a little migration. So right now, our Rails is used for internal applications as well as our customer-facing website UI, and we call that Atlantis, and is used by a MySQL database, which if we did it again, it would be Postgres. But back then we used MySQL. So, and the reason is we wanted to go fast. Is the team was very much smaller back then. For majority of the lifespan of DigitalOcean for the first 2 years, there was probably less than 6 developers working on internal applications as far and as well as the customer-facing applications. So we needed a framework that let us go fast. And Rails let us do a lot of features and go fast, but obviously at a cost, right? At what cost, right? So maybe you know, like, if you work on the same code base over and over again, it will just, it will just continue to expand and break apart, right? And this happens time and time again. There's no way around it unless you're extremely disciplined with your processes. So let me talk about the difference why it's important that my team works on internal applications as opposed to customer facing. When we fail, it's not going to affect millions of customers. When we fail, it's going to affect one team, and they'll let us know that very second, and all we need to do is revert a change. So that made it very simple for us to take risk. Because if we failed, it didn't cause a PR nightmare. It didn't affect millions of customers. It usually affected one team, because we weren't going to make some drastic changes that affect teams cross platforms. We affected one team, and that one team couldn't do their work for 10, 15 minutes. So the cost was very, very minimal, and that was a huge advantage to us in experimenting with the internal tools first. So why break it up now, right? One of the main reasons is the code base expanding. It got very complicated, and it slowed us down. And what was the main goal, right? We still wanted to go fast, and we couldn't because it slowed us down. It kept slowing us down. Now we couldn't go fast anymore. It was hard to remember each code, especially when you work on one feature on this side of the code base. Let's say I'm working on tickets 1 week. So I don't touch tickets for 3 weeks, and then all of a sudden on week 4, and then I work on another project, head in for 3 weeks, and then I have to go back to working tickets week 4. It's hard to remember where each dependency lives. So that made it very hard for us to find dependencies. So splitting it up would make that much easier. And to bring people up to speed, as you can imagine, was not really a pleasure. And understanding the context of the PRs was not fun. I would find myself, I would have to open my own text editor to files that had nothing to do with the PR just to understand what was going on and how things worked. And obviously that's not ideal because we still wanted to go fast. If we took long for PR reviews or people didn't want to use another 10 minutes out of the time to review PR, that was slow it was down. And debug. So a few months ago I got woken up for, on PagerDuty obviously, for a bug in Atlantis. What does that tell me? Nothing, because all our code is there. Like, that doesn't tell me anything. Like, most of our, 80% of the internal tools code is Atlantis. So the first 15 minutes is finding where the bug is, and then you have to fix it, solve it. So ideally, you want to wake up and know exactly where the bug is in which applications, and if you're working on it, the context of that would be much simpler, and you would know the dependencies. And we mentioned that it was really slow. So what were the goals, right? Why? So I already told that, like, we want to go fast. So also, to break up the code, we also allowed us to break up the teams. When you break up the teams, let's say we break up our code base. Right now, our ideal goal is the next 2 years to break up the code into 4 parts and to break it into 4 teams. When you have 4 people working on a smaller code base, everyone's on the same page, the work is more cohesive. Easier to review PRs if you're on the same team, because I know exactly all the code that you are working on, you know all of mine. And it's just, I think it just helps you work much faster, less context in your head, there's less things to be confused about. And it's the total opposite of the big code base. Easy to diagnose, easy to find bugs. If you wake up on PagerDuty, it's not so bad anymore, right? It's except for like when you lose a little bit of sleep, right? So it's not so bad anymore. And updating framework is actually one of the best things about this, because we were on Rails 3 for the longest time, and to upgrade to Rails 4, fail time and time again. Usually when you fail, it's because of the local file or things that no one cares about, but that's gonna stop you, and to fix that, it's a nightmare. I remember one of the engineering managers now, in his former company, he tried to upgrade from Rails 3 to Rails 4. He failed 3 times. He even hired the person who wrote the book on upgrading from Rails 3 to Rails 4, and he failed, and he quit after he failed. So it's not easy. It's not easy. So I'll go what's to break this up. So obstacles, right? I'm pretty sure everyone here is on probably 90% at least is on the same page. Most engineering teams have limited amount of resources and time. Not many managers, especially executives, want to split the team and have the team work on splitting up the code base, which means now half the team is not working on new features. So it means that you're cutting resources. So there was definitely some internal pushback of, is this worth the cost? Is this worth the investment? And that's something that you have to decide. If your company is growing really fast and you need to get features out the door, then it's probably not the right time to be splitting up the code base. But if the company is at a point where this is a big drag and it needs to happen, then there's something that you may want to go and leverage at that point. So this will explain itself. A lot of times, the biggest fear is we want to take one step forward and just get over with, right? But as you know, in the world that we live in, you make one small change and the unexpected happens. You make one small change and the unexpected happens. And so that's the biggest fear. It's every single developer who's done this job knows that you make one change and something drastic crashes. So is it worth the cost, worth the resources, right? So that's something that is leverage. So where to start? One of the popular, I guess, developers out there and who blogs a lot, Martin Fowler, calls this bounded context, which means that you split up something that share the same dependencies. It's simple, right? I mean, it makes sense. So if these 3 things share the same dependencies, let's take that part out first. So that's exactly what we did, and we called it chip log. So chip log is what we use to monitor the health of our servers in the racks and data centers, and to see if you were to create a server, which we call a droplet, it would just monitor that, make sure the creation was successful. If it failed, why? So we took logs. So we call it chip log. And all we did was we just changed the namespace endpoint. We created a new endpoint. And instead of putting /monitoring, we called this /chip log, right? So in doing this, there was very low risk for us. If it failed, then people can just go to the old endpoint. But if it's successful, then we can deprecate the old endpoint. But so basically, all we did was do something that's low risk. It was easy to buy in, because you needed buy-in from your managers, from his manager. So some of the challenges that we still face is quickly and provisioning the new servers. As Rails developers, asking another team to help us provision servers or something that already is getting internal pushbacks probably wasn't a good idea. So for us to have to do this on our own definitely was a challenge. And now that we finally have done it, and we definitely have much more buy-in, this is continuing to be a big challenge. Right now, we do have a few people on the team working on Docker and Kubernetes containers to make this experience much easier. But as of right now, it's still a little bit of a challenge and a pain to go and provision new servers correctly and uniformly. Obviously, you don't want any differences in. Getting buy-in is still a little bit of a challenge, especially if your team is understaffed. So ideally, we would like to hire more people. So if anyone is interested in doing on the Rails side, please let us know. So let's talk about if it worked, right? How do you know if it worked? First of all, I mean, obviously, we have to test it, make sure it works. And we have to monitor the usage of the new endpoint and monitor the usage of the old endpoint. I mean, we did something very similar. We use Skylight. I do integrate Skylight, make sure people are using this one more so than the other one, and there's no complaints. Ideally, they'll see no decrease or improvement, and they'll have the same experience. And in that case, we have succeeded. So what's next, right? It's the best part. You remove legacy code that we did not write. So no one wants to inherit code that is complex dependencies and you have to figure it out. I didn't understand what yak shaving was until I inherited code with dependencies and digging. And so now I understand. And when you work on code that you wrote or your team wrote, it's much more pleasant because you had a hand in reviewing it. You know exactly why they did it and the context and what projects that they worked on. So it was much more pleasant to work on. Now we're able to work on more complex things, proves that we can do it. And I know a lot of companies start off with a Monolith Rails app. Someone I met when I was a attorney, Alex Payne, was one of the first engineers at Twitter, and they also started off as a Monolith Rails app. And eventually, they need to split off because of the complexity of it and the performance needs, and they went to Scala. I'm not sure what we'll go to in the near future, but I would say 5 years, maybe we'll have mobile go back in, but as of right now, we will stick to Rails and we will continue to build services and microservices off of Rails and no more MySQL. I think from now on, we're going to stick with Postgres. So, and now, once again, we are fast and we can be happy. So, let's take some questions if everyone has any.
Sounds great. Yeah. Thank you. All right. So questions about GIFs or otherwise. I spent a bunch of time trying to find the puddle jumping GIF to tweet out. Well, question for you. So you mentioned breaking a product apart so you could work on it in smaller teams. Mm-hmm. What's the team size you guys are using at DigitalOcean right now?
Right now, I would say most teams are 4 to 6 people, and we have 4 to 6 people on what like I said, we call Atlantis. So we like to split that up into 3 or 4. So obviously we want to upgrade our teams up to like 12 probably, but right now I think the sweet spot is probably 4 to 6, and I think when we split up a smaller code base, probably 3 or 4 would be ideal.
Interesting. And then is it a team of 4 or 6 that pulls apart the feature to bring into its own container?
Yeah, I think one or two people would do that, and then once they finish doing it, they would jump back on building features. But yes, it's as you know, like when the company's growing, there's the backlog of features and the expectation of how fast they should be getting done is hard to juggle.
Right. And then when an engineer finishes a given feature on a code team, do you guys continue to work together as a group, or do you get reassigned to a new team?
Oh no. Our team was an internal application, so a lot of features are part of it is after we finish that one, we'll continue to work on the same code base. Like we don't want to jump teams because my team, like I said, works on Ruby and Rails. We do a little bit of Ember and whatnot, but jumping to what we call the storage team will require vast knowledge of the server-side engineering and Go and Libvirt and virtualization and that sort of thing.
Okay, cool. And then any questions from the crowd?
How much effort do you put in testing for internal applications and in comparison with the consumer-facing applications?
Testing is fortunately, I'm very happy to say that testing is a huge part of our culture. I think in Rails and Ruby community is huge, but also just across the company is testing is a big part of everything that we do. There's many PRs that get shut down because they don't have because they aren't tested. So testing is a big part of our processes.
Is it equal for internal applications and for consumer-facing applications? Or?
Absolutely. I do think it's probably a little bit harder to. I think probably a little bit harder to do customer-facing just because you're dealing with JavaScript, but definitely both teams are very disciplined in testing.
When you talk about breaking up that Rails monolith, are you breaking it up into separate Rails apps, or just trying to sort of like silo?
It's totally so new to Rails. Rails new is Rails space new. Is completely Rails new app. And ideally, in the perfect world, you would only talk to each other via HTTPS. You know, that's the ideal goal. Is each one would just supply an endpoint.
So are you breaking up a lot of your basically internal tools into microservices? And if you are, and that's the long-term goal, how do you manage loading in each? I'm assuming each microservice has its own database, so how do you manage that process?
So his question was, if we continue to break up everything into a microservice, will each one have its own database? So is that right?
Yeah, and how do you manage?
Oh, and how do we manage that? So it's two things, right? We used to have a shared database, and that would and ideally I think that's a big no-no because basically it's a single point of failure. Even though of course you will have backups on that database. So yes. I don't think each microservice will have its own database, but I think so. Basically, let's say in my team right now, we work on internal tools for the support team and internal tools for the billing team. So in the perfect world, billing will have its own database, and billing may be composed of 6 to 10 microservices, but they will share a Postgres database, and then the support team will share one database. Each microservice I don't think makes sense to have. Would make sense to have each database, but I wouldn't be surprised if there are services where each one has its own database because as mentioned, we wanted to speak through HTTP. So basically if you did want to do the different databases, it'll be fine. Because as I said, you do want to break it up when they share the same dependencies. So since they're not sharing the dependencies, you could theoretically split up databases too.
How do you manage your dependencies? When you originally came with the monolith that you were talking about, a lot of the code must have shared a lot of that.
How do you manage that?
Yeah.
I think you ask the person who's been there the longest, hey, do you know where this code is? I mean, I'm sure there's a better way, but that's what I did. Slack, hey DM, hey, where's this live? Have you seen this before? It's like, hey, do you know who worked on this? Get blame. Hey, why you do this? So I mean, that's the only way we did it because it was a lot of chasing. It was a lot of chasing. It was hard to manage. Obviously, naming is a huge part of it. You names correctly, then you can find a lot of the files. But sometimes, if one person from back in the day was terrible at naming, didn't take it seriously, that caused a lot of headache. But in many cases, you can track it down by namings and just following the stack. And I do find myself asking some people sometimes.
Cool. Thank you very much, Ken.
Thank you.